மேம் ஸ்டார்ட் பண்ணுங்க மேம். மேம் Shanti. Ma'am, you have muted your mic.
My voice audible, Sweta ma'am?
Yes, ma'am.
Is my voice audible?
Ma'am, now audible, ma'am.
Yeah, thank you, sir. Good morning, all. It gives me immense pleasure in welcoming Mr. Srinivasan Thanukrishnan for this generic talk series. I have the pleasure in introducing Mr. Srinivasan Thanukrishnan. He is Chief Technology Officer and Director of Glosys Technology Solutions Private Limited, a software product company incorporated in Chennai. He plays a key role in defining the strategy in terms of business development, resource management, technology transfer, benchmarking, co-joint analysis, process improvement with his 25 years of IT experience. He focuses on providing collaborative leadership to product research and development, offering services and building it higher to create a sustainable value and gain a competitive edge with an array of dedicated professionals in IT sector. His primary interests include artificial intelligence and data analytics driven security smart SaaS applications for business. He is instrumental in designing and developing products for Glosys Learning, Glosys HCM Cloud, Glosys Health and Glosys Analytics platforms. He has earlier held the position of Senior Researcher at Indian Institute of Technology, Kharagpur. He published 60 research papers in various reputed international conferences and journals, including the role of a program committee member, reviewer, and session chair. Based on his outstanding research service, he has been selected as a candidate for inclusion in the edition of Marquis Who's Who in the World, New Jersey, USA. He already offered consultancy services to various IT industries, including CTS, Satyam Computer Services, Sintel India Limited, and Wipro Systems. He is a member of professional bodies, including ISTE and Internet Society USA. He is an industry representative for academic institutions for AICT and Confederation of Indian Industries Survey. He is a frequent speaker at industry and academic events through active involvement in offering hands-on tutorials, that is keynote talks in reputed international and national conferences, workshops for data science using Python, R and Scala, deep learning using PyTorch and TensorFlow, big data and Hadoop, AI-driven blockchain, cybersecurity analytics, cloud-based IoT analytics using Raspberry Pi and ROS, AI-based mobile and web application using Node.js, ROR, Golang, Flask, Spring Boot, Angular, React, Android, Flutter, and FTPs and entrepreneurship and business schools, panel discussion, application development, hackathons, and expert committee member. He holds a master's degree in computer science and engineering from Anna University and a master's degree in business administration from University of Madras. We are very much delighted to have you here, sir, and we are eagerly waiting to gain from your knowledge, that is from your whatever you are sharing. We are very much interested in taking an output from today, sir. Thank you.
Okay, thanks a lot, madam. Can I start sharing the PPT?
Yes, sir, you can, sir.
Yes.
Is it visible, madam?
Yes, sir.
Madam?
It is visible.
It
Yes.
is visible. First of all, I would like to express my sincere and profound thanks to Dr. N. Gangadharan, sir, HOD ECE, RMK CET, and RMK CET management, principal, professors, and students for having invited me to deliver a technical talk on embedded AI and its impact on industrial applications. I came to know that the targeted audience is heterogeneous group, not only students, professors, and also the parents and others may also be able to view such kind of PPT through YouTube streaming. So accordingly, I project certain important concepts in a generalized and a deeper way also. Let me go through via these important topics. First, we will spend a few minutes on overview of embedded AI and what is the importance of embedded AI and what are the architectural components of embedded AI while you are going to develop any project from the point of development or research. What are the industrial applications of embedded AI? How embedded AI has made a strong impact with respect to a variety of industrial applications which we are leveraging, and we will see a few case studies for embedded AI. First, I will get into the embedded AI. Let me explain each and every concept very clearly in such a way that everyone can understand. The whole idea behind the embedded AI, why it is becoming very popular for the recent period. Earlier, we developed the AI models and deployed on the cloud. Now, because of the technology embedded AI, we train the model on cloud, but deploy the AI model on embedded system. There is a slight differentiation. That means the model is created or the AI model is trained on the cloud because I may be using a lot of complicated deep neural networks or generative AI, what industries are using currently, apart from the traditional neural networks and other ML models. So now, naturally, you can have the view behind the integration of AI and the embedded systems. So these two core subjects are combined together to achieve the desired goals for any industrial applications. When we talk about the embedded systems, in general, it will have microcontrollers, sensors, and IoT devices, and edge devices, and so on. And when you look at any embedded system, I mean microcontroller or sensor, anything else, will be resource constrained hardware. That means limited memory and limited power. So since the embedded systems have the inborn characteristic of low memory and low power, you may not be able to have even the complex AI model which can be deployed. That's why what we do when we create a model or train a model, we'll be using cloud, and after that we'll be minimizing the size of the model and we'll be deploying onto the embedded system. That's the core idea behind embedded AI. But why do we do like that? While you are going to have any AI model is associated with the embedded device directly, it will be very faster. Otherwise, what it has to do, and the relevant data has to go to the remote place like cloud servers, and there the model has to be executed. That means training and testing and all will be taken place, and it will take much more time. So we don't want to carry out the processing in the remote place. Instead, we want to carry out the processing in the local place. That's the idea of the embedded AI. That means you train an AI model in the cloud, but you deploy onto the embedded system, as I said earlier. So, but the processing is done in the local place itself. That's a core objective of embedded AI, why it is becoming popular recently. Again, when we make use of the optimized AI models, we will be using TinyML. TinyML means tiny machine learning model. And because of the low memory and low power, we will be harnessing the power of quantized neural networks. And the inference will be taken. Inference means the testing, the inference, because there are two things, training and testing. So you will be using the model, or inference will be taken place in the edge engines or in the embedded system itself. For example, a smart camera may be detecting defective products on the factory floor without sending video to the cloud, because you have the AI model which is associated with the smart camera, which is fixed within the smart industry itself. The smart camera is capable of detecting the product. So for defect detection, that defect detection should be done through computer vision or image processing. Basically, this problem is coming under the object detection. For example, when I have some object and there may be different sub-objects or regions. For example, the cat is chasing the rat. There is a picture. So there is a cat and there is a rat, two pictures. And how these two objects, cat and the rat, in the available image can be detected through the computer vision, CV packages. In reality, we will be using computer vision packages or pill packages or SK image packages. In terms of implementation also, I'm telling, so that everyone can have clear view. And also, not only we'll be using packages, and behind the packages, we'll be using the algorithms and how the object can be detected. Whether the object will be detected immediately, no. So you will be moving with the low-level features to the high-level features in terms of AI. So you can detect the straight line, or you can detect the blob, or you can detect the curve, or you can detect the edge. So all the low-level features will be extracted from the first layer to the last layer of the any neural network. So you will go to the high-level features. That's the idea behind deep learning. Because when you talk about embedded AI, the moment I say AI is a very big subject. It includes machine learning, and machine learning will be having deep learning, especially neural networks. Again, presently, all of us are using generative AI. It is one of the major components behind deep learning. So all these things can be associated with any embedded system to achieve the task. So while you are going to look at the architectural components of embedded AI, you have embedded hardware and software frameworks and other two major components, AI models and deployment environment. We'll discuss one after another. Because for any kind of embedded AI projects, when the students or the employees or the developers in the software industry or the hardware industry or the professors or anybody, people involved in the embedded AI group, how do they develop the projects? When they develop the projects, first of all, then they are supposed to have the infrastructure behind it. So basically, I need first embedded hardware in terms of microcontrollers. You can have even ESP32 microcontroller or Arduino microcontroller or Raspberry microcontroller or ARM Cortex-M. All these microcontrollers, any one of the microcontrollers, you can select in accordance with the requirements of the clients. Apart from the microcontrollers, presently, Google is having its own AI chip called Coral, Google Coral. Similarly, Intel is having MoviDS and NVIDIA is having Jetson. These are the latest technologies with respect to the embedded AI. And these chips are available even in the market. You have to pay the amount for that. It's not a free version, and you have to subscribe for that. You have to pay the amount. And in order to implement the embedded AI projects, and you need to have the sensors related, temperature sensor or vibration sensor, or you can use any kind of sensors depending upon the requirement of the problem. And you'll be using the IoT device like Raspberry or Arduino, which may be associated with the IP addresses. So Internet of Things devices. So basically, having had such embedded hardware components, next part we are going to discuss about software frameworks. In the software frameworks, we have a separate TensorFlow Lite for microcontrollers. That's a beautification behind this embedded AI. Because normally, when you use any AI projects, especially deep learning projects, those projects could be developed using TensorFlow or PyTorch or Keras or Scikit-learn in terms of machine learning. But for the microcontrollers specifically, they have a separate version, TensorFlow Lite. TensorFlow Lite. You need not use the traditional TensorFlow library, which is being used in the deep learning projects. So TensorFlow Lite is available and you can download it, and corresponding packages will be used while you are going to make use of the coding corresponding to the TensorFlow with respect to the microcontroller which you are using. Similarly, alternative of the TensorFlow, you have the PyTorch, another library. Just I am telling the library. Similarly, you have TinyML toolkits. So these are the equipments or the softwares. So embedded hardware equipments, software frameworks, TensorFlow, PyTorch, Mobile or Edge Impulse, TinyML toolkits you are supposed to have. And not only that, when you are going to develop the embedded AI projects for any industrial applications, we will be seeing a few industrial applications in continuation to this. You need to have clear understanding of the AI models from the scratch to the advanced level. So the classical machine learning, we have supervised learning, unsupervised learning. In the supervised learning, you will be having input and output features. Everybody knows that with respect to the AI, your input will be the data set. Data set is nothing but the table. The table will be having a set of rows and columns. The rows, I can call it as samples. The columns, I can call it as a features. So every data set will have a few samples. For each sample, you'll be having features. For example, you are interested in purchasing the house. So how I can predict the house price? In order to find out the price of the house, basically, you will be looking at the square feet of the house and number of bedrooms and number of floors and locality. So let me take these 4 features. Based on these 4 features, you'll be able to find the price of the house. So this kind of problem, for better understanding for the beginner's point of view, I'm telling this is the nature of the data set. So you can have 1 lakh samples or 1 crore samples. Similarly, how I have mentioned 4 features, similarly, you can have n number of features. So n number of features, m number of samples. So the problem will be very big. So you have the data set that is going to be input for the AI model. And you can use the regression for predicting the Y for the given input features, or you can use the classification algorithm, neural network or supported machine or decision trees, and so many algorithms we are having under the machine learning. In terms of deep learning, specifically, we have convolutional neural networks. A lot of CNNs are available, LeNet, AlexNet, GoogleNet, ResNet, MobileNet. All these predefined models we may be leveraging in order to deal with the computer vision projects, especially image segmentation. Suppose I want to segment the particular object from the given image. What image segmentation you are going to use? And how do I detect the image? I already said that the cat is chasing the rat. So there are 2 objects. These 2 objects can be detected after segmentation. And RNN for predictive maintenance means basically RNN is nothing but recurrent neural networks. And these recurrent neural networks normally you'll be using for the text analytics. Text analytics means, for example, all of us, we keep sending and receiving messages through WhatsApp and social networks, Facebook and LinkedIn. So most of the time we will be having text messages, and using these text messages, how do you do analytics? So your documents, your text, suppose I keep on writing 5 sentences, let it be a document or paragraph, and how AI will be able to derive the insights from the given document. That could be done through RNN. Better example, suppose I am asking the question, what is the capital of the France? Suppose I'm writing something like the capital of the France is Paris. the moment I type the capital of France is the one of the possible answers Paris, it will be having the more score. So the basic idea behind the RNN in terms of deep learning is you are predicting the next word in the sequence. Predicting the next word in the sequence. For example, the capital of France is, this is the sequence. The D is one word, capital is another word, off is third word, France is fourth word, is fifth word. So 5 words. What is the sixth word? So the capability of the RNN is capable of finding the RNN is capable of finding the Paris next word, predicting the next word in the sentence. This idea began RNN. And the advancement of the RNN only, presently we are having one AI tool. All of us are familiar, ChatGPT. That is internally using the architecture of the transformer. So transformer is also capable because the expansion of the ChatGPT is ChatGPT, generative predefined transformer. That is a transformer neural network architecture. So that new transformer neural networks is capable of dealing with the both image processing and the text processing or audio processing or video processing. That's why people are very much interested in making use of ChatGPT or DeepSeek and other Microsoft Copilot or Gemini, Google Gemini, and all these Gen AI tools are dominating the entire world. So why I'm telling all these things, all such AI concepts may be associated with your embedded systems. And basically generative AI is capable of generating the text from the given text, generating the image from the given image. Suppose I give you 50 images, can you generate the new 51st image? Yes. So from the given 50 dog images, I can generate the 51st dog image using the generative AI. That's the idea. And that is a pillar, that is a cornerstone of ChatGPT. An explainable, responsible AI will be dealing with the advanced concept of deep learning and generative AI, and whatever model we are developing, whether the model is trustworthy or not. Suppose normally we use the algorithms, but in terms of the industries, how do they come to the conclusion that the model is giving the correct accuracy? They won't believe. So they need a trust mechanism behind the algorithm also. That's why currently the research is going with respect to the explainable and responsible AI. The AI has to be responsible. It can give even the false answer. So how do we ensure that the AI is behaving properly? That is the current research of AI. So now I have given the idea about embedded hardware and software frameworks and AI models. And fourth one is, having had these three major components, the fourth one where you are going to deploy. You can deploy onto the microcontroller, you can deploy onto the FPGA, or you can deploy onto the RTOS associated with the your embedded system and embedded Linux or bare metal systems. So with these basic four major concepts only, it is possible that anyone can develop any scientific or business oriented embedded AI project for any industrial applications. Now we will get into the a few industrial applications of embedded AI, one after another. So I will touch upon a lot of industries. Finally, we will see only one case study of the particular industry depending upon the available time. Now let me get into the manufacturing and industry 4.0. In the manufacturing industry, what's happening? What is the role of the embedded AI in manufacturing? I have specified three different problems: predictive maintenance, defect detection, robotics. Defect detection, I already said. Smart cameras are capable of detecting the defects in the factory floor using your CV packages, computer vision. That's what the second one, defect detection. Embedded vision cameras detect faulty products on assembly lines in the smart factories. The predictive maintenance, AI models on vibration sensors predict machine failures. That means, suppose there may be a lot of machines available with respect to the particular big industry. It could be anything. It could be automotive industry or textile industry. What kind of fabrication you are going to do? Suppose it could be the Ashok Leyland or anything else. So nowadays the AI and automation are mingled together. So you will be having vibration sensors, and using those sensors only, actually you are collecting the data. Initially I said the data set. Data set will be having multiple samples, and each sample may be having multiple features. But normally, if you are not using embedded AI, and when you use the AI alone, the data set will be the input. But wherever you use AI, from where you are collecting the data, that is a question. Suppose I say the data set I have means 1,000 samples, and each sample is having, for example, 100 features. From where you are collecting the data? You are collecting the data from the public data set or private data set. But in industry, what we require, we need a real-time data set. So with respect to that environment, you have to capture the data through the sensors. That's why it's becoming very popular. So predictive maintenance. So prior to occurring, whether will you be able to predict the failure before it happens? So you are able to collect the data through the vibration sensor. After collecting the data, you'll be having the data set. Then you apply the AI model, and that AI model will be associated with the embedded system. Then you are able to predict the failure. This is the way the problem goes. We will be seeing one case study in detail at the end. And the third part, even in the manufacturing, presently in lot of places, we make use of robotics. When we talk about the robotics, robotic can have robotic arm. With the help of the arm, it will be capable of picking the object. It can recognize the object, and it is having its own control through the adaptation. And second industry, what we are going to look at it, automotive and transportation. With respect to the automotive and transportation, I will spend few minutes. And this is the problem like the vehicle. You can see the different type of land vehicles or water vehicles or aerial vehicles. Whichever vehicle you are going to deal with, certain concepts are very common and certain things will be varying. In the case of autonomous driving, because the future is autonomous driving, even currently, even autonomous cars are available in US and Europe, and certain investigation is going on with respect to certain experiments. So while you are going to have the autonomous car and you don't need the driver, so the car itself will be driving on its own, how it is going to detect the lane and how it is going to recognize the obstacles which are in front of it or which are even side of it. Whatever way, the AI should be there. Without AI, you can't do it, because you may be having the electronics associated with the car or electrical components, and you may be having the mechanical. Mechanical means fabrication side, your chassis and all. And electronics, you will be having automotive electronics will be associated with the autonomous driving in terms of even sensors, again microcontroller, communication systems. Communication systems will also play a vital role within the car itself. Okay, even you can control the car from the remote side also sometimes if you want. So what kind of communication systems you are going to use, whether you are going to use Wi-Fi or you are going to use GPS, and which kind of wired communication or wireless communication, everything you can assume by yourself based on your constraints. You configure, you fabricate your autonomous car. So in the case of driver monitoring, suppose semi-autonomous car I am discussing now, because there is a driver monitoring. So in that case, presently, how do they deal with the problem? There is an opportunity for us to detect the drowsiness or distraction via camera sensors. So when you have the camera sensors, in the case of semi-autonomous car, there will be the driver, and the drowsiness of the driver can be detected through the camera sensors. So every time the camera sensors will be collecting the status of the driver, and it will be sending those data frequently to some sources. So data set is generated, and again you apply the AI. If there is any deviation from the normal condition, so when you happen to find the abnormality, the alert will happen. That alert will be sent to the driver through some app or some other mechanism. So there you can use even web app or mobile app, something like that. So the third major sub-problem in the automotive transportation, what we are discussing is fleet management. So edge devices optimize routes and fuel consumption. With respect to this is not an electrical car, fuel consumption I'm talking. But nowadays, electrical car is also coming up. So fuel consumption and how do you optimize the routes? So route optimization is a very big problem, because when I say route optimization in the traffic control, you need to understand the whole network, whole map, Google map, okay, the route, what are the stations are connected, what are the roads are connected, which is the shortest path, which route you can take, everything. Suppose you move with the car, suppose autonomous car keeps moving, and how does the car know in advance about the congestion when it is going to happen in some other place, and that congestion information should be known to the autonomous car in advance. Accordingly, the autonomous car can take some other route, either in the semi-autonomous driving or autonomous driving. All these concepts are associated presently. Now let me get into this autonomous driving to some more extent. If you look at this issue, this problem, this industrial application, what actually you are doing, definitely you need to perceive the complete environment in front of the autonomous car, and you have to sense the environment. You have to sense the environment. The autonomous car, the autonomous vehicle has to sense the environment. What about the pedestrians? Where are the pedestrians? And what about the other vehicles in front of that particular car? What are the obstacles? When the obstacle is going to happen, what decision the autonomous car can take through the AI algorithm? So everywhere your AI is coming, that model is going to be executed or tested on the microcontroller. Now the microcontroller will be helping, because as I said earlier, you are not, I mean, the model will not be deployed on the cloud. The model will be deployed directly on the microcontroller itself. That's a major difference between embedded AI and the AI driven cloud. Here, we do not use cloud to a greater extent, but at the same time, when you create a model in the initial side, because for training the model, we need cloud. So 50% of the help we are getting to the cloud. And when we are going to deploy that model onto the embedded system, we use the microcontroller. That's a basic different slight modification or the borderline difference. You have to have clear idea. And the second aspect in the autonomous driving is mapping and localization. What we mean by mapping and localization, and when the autonomous vehicle keeps moving on the road, it is supposed to know the map of their surroundings. It could be done through Google Map, or presently earlier what happened, Ola was using Google Map. And after some time, it has realized that why I have to pay the amount to Google. Instead, the Ola started developing its own map. So what suggestions I would like to tell towards the students of RMK CET or other RMK group of institutions, why you should not discover or apply your creativity and innovation with respect to the mapping software, which may be closer to the Google Map. You should not use a Google Map API. Presently, what is happening, people use Google Map API and they put only one line in the backend. They say that I'm using the map. No, that is not your invention. You are using only one API. Sometimes, suppose the translate is there, right? Even the autonomous autonomous vehicle is having the capability of speaking with the user, okay, capability of speaking with the passenger. And so it has to speak. So depending upon the language of the passenger only, it has to speak. Normally, by default, English will be there. Suppose the Japanese passenger is driving the autonomous vehicle. So Japanese language and the autonomous vehicle has to speak. How it will speak? So naturally, a speech recognition will come, and multiple languages are integrated. So the moment you say multiple languages, normally people use Google Translate API. Don't use Google Translate. You use Google Translate API for projects. I'm not saying like that. But with respect to the innovation point of view, can you develop translating system from your end, from the scratch, so that one language can be converted into other language? That is the hardcore of the AI research called machine translation. Normally, CSE students will be doing like that. But innovation is much more required for India, even though we have a lot of products. Okay. And so I'm describing about the working principle of the autonomous driving along with the embedded system and the AI together. So far we have discussed about the AI, but the third part, electric motors. Now we get into the slowly the embedded system. So motors are coming from the electrical line, and naturally the motor will be there in the car, and inverter will be there, The battery system will be there, battery management system will be there, onboard charger, vehicle chassis, vehicle control unit, battery status, range, and charging. So you can bring innovation and creativity onto any one of the battery management system, or you can design, you can make some modification in the partial design of any induction motor like that to design and fabricate your drone. Suppose autonomous car, so far I told, even when you talk about the drone, it is going to the aerial vehicle. So in the aerial vehicle itself, what is happening? You'll be having a lot of sensors, GPS sensor, IMU sensor, accelerometer, gyroscope, everything will be made available in the drone. Again, the heart of the drone is even your electronic control unit associated with the intelligence part. Again, you will be having other major components associated with that. Okay, so the you and ESC, electronic speed controller will be having even battery management system, battery distribution system. So it is somewhat the drone will also be following the similar characteristics of the autonomous vehicle, but with respect to the flying nature, certain things will be vary. So please try to do the comparative study with respect to different types of vehicles when you get into the any project. What are the differences among land vehicle, water vehicle, and the aerial vehicle, like that? And again, as I said earlier, the drones, after putting lot of efforts from the mechanical side, they will be putting lot of efforts for composite materials. Okay, composite materials or small drones. They may be using some kind of the materials which may be extracted from 3D printing, something like that. So depending upon the ABS material, so lot of materials you may be using. And once you design your vehicle chassis from the mechanical side, you come to the electrical part, electrical motors and inverters. Then you come to the electronic side and microcontroller, your sensors, your communication module is very important. How the communication is going to be taken place from the drone which is flying on the flying from the greater height from the ground station, and how do you control? Lot of things are the receiving end and sending end. What are the problems occurring with respect to the communication medium? So in each and every aspect, your intelligence is there. But AI may be associated primarily with the microcontroller or Raspberry Pi or ARM or even Google Coral or NVDAs. I said Intel NVDAs. These are the advanced AI chips. And not only the Google, I mean, you can deal with the drones in this direction, but also there are a lot of capabilities you are associated with the design and fabrication of the embedded AI-driven drones. I'm talking about embedded AI-driven drones to a greater extent. Next, a few applications I'll be telling, depending upon the time availability, I'll be telling to some extent. So even it has to know the path planning. I already said the path planning means definitely it is supposed to know the complete network, aerial network. Okay, in which direction it can fly and how it can go up and down and left side and right side, and lot of things are there. Okay, there are certain parameters like yaw. Okay, and a lot of different parameters with respect to the translation, geometric parameter, translation, rotation, and scaling. Translation means from one position to another position, how it can move. And rotation means how it can be rotated towards the x-axis and y-axis. Normally, when the drone flies, you may be able to see the rotating nature of the drone. And behind each and everything, your geometric primitives and operations are available from the mathematics side. So what you understood from this lecture, from this talk, many things are involved and interdisciplinary issue. Not only I can say that this is embedded AI. Embedded system is basically from the electronic side and AI from computing side, but also behind that, your electrical, your mechanical, and other aspects of the mathematics will be greatly involved while you are going to design and develop and deploy any kind of industrial application project. And especially in the last part, path planning, vehicles, the aerial vehicles learn from experience and traffic scenarios, and it may be having the capabilities of the human computer interaction in terms of NLP, natural language processing, the natural language processing, because it has to communicate with the passenger using the text messages or audio messages or speech. I already said even multiple languages may be integrated, and when the chatbot can be integrated, chatbot may be integrated. Okay, Automated chatbot can also be associated with the autonomous aerial vehicle and all. And when you talk like that, the chatbot is again, it is coming under the NLP, it is coming under the text analytics. Initially, I mentioned about the use of the RNN. I hope the people will be able to follow my lecture very clearly when you are very keen in attending the session. RNN, recurrent neural network, is basically used for predicting the next word in the sentence. The higher level, the advanced level of the RNN is transformer. The transformer is the backbone of the ChatGPT. I already said. So these are the ways by which your embedded AI is playing a vital role, especially in the case of automotive, electronics, and transportation. So I have spent a few minutes on this industrial application. The third one, next I get into the another application, healthcare and medical devices. Lot of applications are available, but each and every application you have to go in depth. You have to study the corresponding problem. What are the requirements? You have to prepare your SRS. Then you have to look at the low-level design, high-level design, and you have to develop and deploy in terms of the industrial deliverables. And the healthcare and medical devices, what we are doing, especially in the hospitals and all, and even the smart watches can be associated with a patient for finding the ECG analysis. Sometimes wearable devices, wearable AI devices can be associated with the patients to find the heart rate monitoring. Sometimes along with the side bed, some sensors may be fixed. And with the help of the data collected through the sensors, AI is capable of finding whether the patient is whether he's going to fall down from the bed or not, because everything you can find from the remote place. So whether it respect to the heart rate monitoring or ECG analysis or any kind of diseases with respect to the different organs associated with your orthopedics or ophthalmology or your lung diseases, many things you can identify a few diseases. Correspondingly, you look at the data set, and that data set may be associated with that data set. For that data set, you have to collect the data through the sensors, and those sensors you have to fix in any one of the places in the hospital, or you have to associate those devices along with the patients themselves. Because if you are going to, if the patient is going to have the smartwatch, or if the patient is going to have the wearable AI device, and even from the remote place, easily you can monitor. Remote patient monitoring can be done. Similarly, blood oxygen monitoring can also be carried out nicely. And portable diagnostics, AI-enabled ultrasound or X-ray devices working offline. And as I said earlier, third point is already said, bedside sensors with the embedded AI is having the capability of detecting anomalies, irregular heartbeat. It can easily be found through such wearable AI device. Wearable AI device, embedded AI devices. Next industry, what we are going to look at it, energy and utilities. Energy and utilities. This is a very big topic. Normally, such kind of energy systems, how do we generate the energy? How do we conserve the energy? How do we distribute the energy in terms of normal grid systems? Or there are many, suppose if we are not capable of collecting the sufficient energy from the grid systems, we have additional alternatives presently in terms of sustainable development goals. There, what we say, even in terms of the solar panel, I can collect the energy, I can generate the energy, and through the wind power, I can collect the energy, or through the hydro power. Okay, what are the different ways by which you can collect or you can generate the energy? That's what we are doing. But whatever you do, there embedded AI will be there. For example, presently all the EB departments, okay, all over India, and is bringing smart meters. So the advantage of smart meter is that the embedded AI is capable of detecting abnormal consumption. Even as a end user, as a consumer, as a customer, at any point, we will be able to know whether do we come across or do we move beyond the normal readings and all. Accordingly, we can reduce our current consumption and all, energy consumption and all. Because this embedded AI will be directly connected to the web app and mobile app. So through your mobile app, you will come to know what is really happening in the smart meter. So everything is connected, please understand. So smart meter will be having some kind of sensors, so it collects the readings, and if there is any abnormal reading, it will be going to the cloud. From the cloud, either through the web app or mobile app, wherever you are, you will be able to know. But in terms of embedded AI, what I am telling, that tiny AI models can be processed within the your low power sensors, or low power sensors or low memory, or your microcontrollers. The second one, grid monitoring. Edge AI predicts power fluctuations, how the power fluctuations can be predicted, and how the blackouts can be prevented. As I said earlier, wind turbines or solar panels. So PV, and you need to know solar PV, embedded sensors in association with the wind turbines or solar panels, how they are capable of detecting failures, and what are the current methodologies for optimizing efficiency. Everything can be handled through the AI mechanism. So everything is the calculation oriented. You need to have a very systematic approach by which you can arrive at a solution. Next part, we are going to touch upon agriculture. In the case of agriculture, you know very well that how I can monitor the crop health. So how you can deal with smart irrigation. And normally in the hackathons, normally when I happen to go and act as a jury member for many hackathons, it could be MSME hackathon or Startup India hackathon or any funded projects, and students or professors used to deal with such kind of problems, and you may be going to some extent, but again beyond with that, some prototype, you need to know how to deliver certain products like industries. So smart irrigation, AI sensors optimize water usage. So water usage in the sense that, first of all, you have to understand about the area or the whole area coverage of the particular land, okay, where the agriculture is going to be taken place, and what about the water usage, and whether automated smart irrigation is possible, because depending upon your requirement, the water usage may be increased, sometimes water usage may be decreased. That and all, the decision may be taken by the AI algorithms. And crop health monitoring, embedded drones. I already given a clear picture about the embedded drones. We have seen different components of the drones prior to this agriculture industry, and the embedded drones with the AI detect pest infestations. Pest infestation means, for example, and what you can do, the pest and the pest detect pest infestations, or sometimes they can spray some some kind of things, and when the plants are going to have the disease, so what type of things, and you are agriculture from the agriculture industry, and for the better benefit of the farmers, okay, you are going to spray. And also, how do you control the pest, and how do you control the weed control, pest control, how do you improve the yield, how do you improve the yield of the particular agriculture, and what which component you are using, whether you are going to use a rice or wheat, and which vegetables or fruits, that and all matters, and that you have to specify, and soil moisture. So these problems will be associated with the agriculture industry, and there you have to bring sensors and the microcontrollers. You have to have a clear-cut architecture. In the livestock monitoring, this is associated with the somewhat another important issue with respect to the health of the animal health and behavior. Normally, the veterinary hospitals, and they need the requirement of such kind of problems, livestock monitoring, and there you may employ wearable AI collars, and which are capable of tracking the behavior and proper health monitoring of the animals, so that the animals can be protected from the diseases. So what do you do? How do you attach the sensors associated with the animals, and wherever the animals move, and they will be carrying certain embedded AI devices, so that you will be able to know about the whereabouts, where the animals are. Sometimes in the forest management and all, even 2 days back, I happened to see some news from the TV channel, and even for the the living organisms within the sea. What they do, they associate the sensors with a very big, living organisms available within the sea, so that they are able to find the movement, and also they are able to find the healthy condition of the animals. Again, the next problem, smart cities and infrastructure, and it's a very big problem, because nowadays wherever you go, you have a traffic control. How the government can solve this issue? You have the embedded cameras, and these cameras should be capable of optimizing the traffic signal. And even public safety is again another big problem. So wherever the accidents are occurring, how do you detect? Wherever the fires are occurring, how do you detect? An unusual crowd behavior. Unusual crowd behavior means, suppose when the new movies are going to be released, or when during the festival seasons, how do you detect the unusual crowd behavior? That and all could be analyzed through the problem called gait recognition. The way in which how the people keep moving, or face recognition, unusual faces, or sometimes what happened, the police department, they may be having the criminal records, and correspondingly they may be having the facial readings of the criminals and gait recognitions of the criminals, and easily they may be able to detect from the normal people when they are going to move in the very crowded place. And waste management, smart bins with the AI predict collection needs. And finally, we come to the consumer electronics. And we, in the consumer electronics, with respect to the smart home devices, you have voice assistance and gesture recognition on edge devices. For example, you want to have smart home. You want to bring the you want to bring and enjoy the power of the smart home within your home. What are the things you can do? Suppose before I enter into my house, and you take a decision that AC should be on. Okay, so what I can do from the remote place? Can I control, or autonomously it can be done? Or smart fan. So smart fan, smart refrigerator, smart washing machine, all appliances presently moving with a smart device only, because totally the traditional patterns they have changed, removed. And also nowadays, whenever the old washing machines or old refrigerators are going to be repaired, okay, and that can be done. But the current washing machines, recently purchased washing machines or refrigerators, are having the capabilities of the embedded AI, and with the help of that they optimize the energy. Okay, and whatever you do with respect to the smart home or smart appliances, you are the AR VR devices which is capable of detecting this. And next available, just within 5 minutes I'll be finishing only one case study. I can rush it up, just you look at it. So out of these different industrial applications, I would like to get into the predictive maintenance in manufacturing. So how do you solve the problem? Suppose I take one scenario: a motor in a factory produces vibration readings every second. If vibration exceeds a certain pattern, it indicates possible failure. So for example, with respect to the vibration, okay, vibration levels in G force. With respect to the motor, I am telling in the factory. So you take the normal readings and the faulty readings. Suppose normal reading 0.2, 0.3, 0.25, 0.35, 0.4. Faulty readings means if it exceeds 1, you say that faulty readings. So what is happening with respect to the problem? Suppose I take a simple classifier model like I can use the only with respect to the threshold. So whenever the average vibration is greater than 1.0, you can say simply the particular motor is going to be faulty with respect to because of the vibration sensor you are able to predict. And you can have different type of sensor data frequently. So every 5 seconds, for the last 5 seconds, I am collecting some data. So I am taking the average. If it is going to be coming under normal, fine. If it is going to exceed 1, I say that faulty. Now what I do, this is not the problem. Like this, every time you are collecting the data from the sensors, and depending upon the, you take the average within the, then you say that, okay, if you have this reading normal, if you have this reading, I have faulty. So the vibration sensor is giving one data, the result is normal. I have only 2 features. So for the understanding purpose, I'm saying 2 features. One input feature is vibration reading, and another output feature is, that is a class label, that is nothing but the normal or faulty. So naturally, you can have 10 samples or 20 samples or 1,000 samples or 1 lakh samples, even 1 crore samples. The moment you have 1 lakh samples, it becomes a very big problem. Now you have the data set. Using this data set, how do you make use of your neural network problem? So the problem setup will be like this. How do you predict the machine health from the vibration readings? For understanding purpose, I'm not taking a very big data, only the normal machine and faulty machine. How do I differentiate? So you create a synthetic data set, train a neural network model, write it in Python, and prepare it for embedded AI deployment. It could be deployed in the FPGA or microcontroller. That is the problem setup. Step 2, you have to use any one of the classification algorithms from the deep neural network, CNN, or neural networks, or any neural network training, neural network or regression you can use. So model behavior, you are look at it, normal or faulty. Then you are going to prepare the model for the embedded AI. As I said earlier, you are creating the model. That means any data set can be divided into 2 phases, training and testing. And training, you will be taking 80% of samples. Testing, you will be taking 20% samples. Based on the 80% samples, you create a model, and that will be done over the cloud, please understand. And remaining 20 samples, you use it for the testing. And the created model, you are going to use it during the testing. After that, you deploy onto the embedded system or microcontroller. So you use a tiny ML as well as a TensorFlow Lite Micro. Initially, I said. So in order to deploy this on a microcontroller, you use Arduino Nano 33 BLE Sense or ESP32. And finally, what do you do? Convert the model to TensorFlow Lite format and quantize it. Why I have to do quantize it? I am reducing the model size. Because of the low memory, low power embedded systems, it is not possible for me to have many parameters. So you are reducing the parameters, so the model is becoming simple, and accordingly you can look at the bias and various properties. Okay, and finally you deploy it in C and C++ code. So the whole idea, initially you write in the Python code, and you convert in the TensorFlow, right? You reduce the model, you put a wrapper, then you develop the C++ code. That C++ code you are putting on the Arduino. Suppose because Arduino is compatible with the C++. So please understand this magic. You are converting the Python to the C++ via the TensorFlow Lite. If you are using Arduino. So depending upon the device, suppose Python, if you are using Raspberry Pi, by default, Raspberry Pi is capable of accepting Python. That case, you need not do such modification. With respect to TensorFlow Lite itself, you can stop. Then you, as I said earlier, you are going to deploy on the tested model onto the embedded system. Once you have the vibration model in terms of the format .tf Lite, you can load it to the TensorFlow Lite micro runtime, use the sensor input from the accelerometer, and you run the inference in the real time for taking a decision. So the overall idea, what we understood over the 1 hour session, with respect to this particular case study, predictive media manufacturing, you are collecting the data through the sensors, you are training the model in the cloud, especially neural network you are using, deep neural networks or generative you are using in the cloud network. And when you talk about the neural network, you know that it is understood, it will be having input layer, hidden layer, output layer, and activation function. These are all fundamentals you are supposed to know. And loss function, because the loss function will be telling the difference between the actual output and the predicted output. You can use some mean square error or cross entropy loss. And naturally, because why I have taken this case study as a neural network, this is the foundation of the future study. Your deep learning starts with the neural network. Your generative starts the neural network only. So no one can escape from studying this neural network presently. And forward backward propagation you are using to reduce the error. Again, at one point, you will be using the optimizer like Adam in the implementation. Again, whichever AI model you are going to use, you have to understand how far the model is very efficient, so that you have different metrics: true positive, true negative, false positive, accuracy, F1 score. And 2 more minutes, just wait, I will be finishing within only one slide is more. So true positive means, suppose you please understand like that. I'm saying normal machine, normal reading, and faulty. Normal machine, faulty machine. So there are 4 classifications. The predict actual is normal. You are predicting as a normal. So 100% correct. That is true positive. And actual is faulty. And prediction is also faulty. That is true negative. And actual is your normal. And what you are predicting is actually going to be negative. That is false negative. Like that, you have another case false positive. And you have some formula begin accuracy. And you will be able to find the F1 score for the metric for this kind of case study using the precision and recall 2PR by P plus R. Finally, as I said earlier, the model is converted to TensorFlow Lite Micro. You are going to deploy the STM32 microcontroller. And with respect to the threshold level. We can go beyond the normal level. The motor vibrates abnormally. The microcontroller AI detects anomaly. The alerts operate instantly. So no cloud is required with respect to the embedded AI. With respect to the testing part, I'm telling. So the impact behind all the application is with respect to the different parameters you may be specifying. And as far as this problem is concerned, what is the impact? It saves thousands of dollars by preventing machine failure. So thank you for your
Thank you, sir. Thank you
Thank you,
very
sir.
much for your information sharing, sir. It was a very useful session. Thank you, sir.
Yeah, if you are having any questions, you can ask. Any questions from the audience?
Sir, they are in YouTube,
YouTube.
so they will post the message.
Okay. Fine. Anyhow,
Thank you.
those who are having any doubts at any point, you can contact me. I am Srinivasan Thanukrishnan, CTO Director, Glosys Technology Solution Private Limited. Once again, before concluding, once again, I express my sincere thanks to the organizers and the RMK management, principal, and Professor Dr. Gangadharan sir, HODC. Thank you.
Thank you, sir. Thank you, sir.
Shall I leave, madam?
Sir, you
Yes,
can
yes,
leave, sir.
sir.
Thank
Yes,
you,
sir.
sir.
Thank you, sir.